Okay, guys, today we're going to finish up polynomials. Well, start to finish up. We may have to take 2 days for this lesson. We're going to be talking about factoring trinomials and special cases. The first type of trinomial that we are going to work with is the type of trinomial that has a 1 as a coefficient of x squared. Remember, there's an invisible 1 there. So when you have polynomials, trinomials in this case, in the form of x squared plus bx plus c, you are going to use the following procedures. Now, one thing I want to just give you guys a heads up on, okay? When you have a positive and a positive, your answers are going to be x plus something and then x plus another something. But when I've got, for example, a plus and a minus here, okay, I have a plus b but a minus c, what happens there is that I'm going to have an x plus and an x minus a number. All right? When I have a minus here and a plus here, I'm going to have an x minus and then another x minus a number. Okay? And if I have a negative and a negative, I'm going to have an x plus and an x minus. Now, that's nothing that is super crucial except the fact that it really helps you when you are setting up the problems. So you don't have to memorize this. Bro. Yes, sir. What's your question? Yes, sir. It doesn't matter. Doesn't matter. What he asked is for the minus minus. He said, isn't it x minus and then x plus? No, because I have something called the commutative property of multiplication. So this x minus could go in the front, and this x plus could go in the back. The point there is when they're both minus minus, one of the values being added to x will be positive, one of the values being added to x will be negative. Okay, now, sorry about all that confusion, guys. So I'm going to erase this, but know that those are the formats. You don't need to memorize that. They're just going to help you out a little bit later. And when we're going through the examples, you'll see why you don't really need to memorize them. It just sure as heck helps. So, okay, we want to factor x squared plus 8x plus 15. My first thing I'm going to do is my setup. Okay, now I have a plus plus here. So my setup is going to be x plus something, parentheses, times x plus something else, parentheses. Step 2, we want to fill in these 2 blanks here. We want to know what the heck those are. So in order to find those out, it's very simple. You simply ask yourself, what times what is the c value, but when added together is the b value? So in this particular case, yes, sir, what times what is 15, but when added together is 8, my man? Heck yeah. 3 times 5 equals 15, and 3 plus 5 equals 8. So, you're done. Literally. Step 3, plug in the answers into your setup. So I have x plus 3, x plus 5. Yes, sir. No, in the instruction it says it correct. What times what equals c, but when added together equals b. So, then maybe change it. Maybe change it if something is wrong. Thank you. Okay, so does that make sense as procedure, guys? Guys, going once, twice, hello? Okay. So let's just do a bunch of them. I'm going to do these fast and furious because they're easy. Okay? Follow my lead, please. You have all these written down, so I don't want to hear I didn't have time to write it. First, your setup. R and R. Does everyone see why I put R and R? Remember, if this was R to the 6th, it'd be R cubed and R cubed. If it was R to the 10th, it'd be R to the 5th and R to the 5th. You feel me? Promise? Okay. So it's not R to the 6th, R squared, so R and R. Now, what times what is 24, but when added together is 11? They're both positive, so positive 8, positive 3, you're done. Number 2, setup. X, x. What times what is 24, but when added together, wait. What times what is positive 24, but when added together is negative 11? Negative 8, negative 3. Remember how I told you when it's negative plus, it's going to be a negative and a negative? See, you don't have to put in the signs, but like I said, it's good to remember, okay? But the way I teach it, you have to know what signs are there because only negative 8 times negative 3 can equal positive 24, but when added together equal negative 11. Okay, number 3, setup. XX. What times what is negative 15, but when added together is 2? Okay, you have positive 5 and negative 3. Very good. Could I have put the negative 3 here and then the positive 5 here? Whoever's saying no, the answer is yes, you're wrong. This is a commutative property. I can switch this binomial and move it over here. Okay? I just can't take apart the binomial, but I can move the binomial because of the commutative property of multiplication. Okay? Does that make sense? So it's x plus 5 times x minus 3. How does that work, Mr. Morrow? 5 times negative 3 is negative 15. 5 minus 3 is positive 2. Does that make sense, everybody? Okay, next, my setup. Y. Okay, I got negative 2 and negative 4. Yes. Negative 2 times negative 4 is 8. Negative 2 plus negative 4 is negative 6. Yes. Next, setup. X. What times what is positive 2, but when added together is negative 1?
1 and 1.
Wrong.
Negative 2 and 1. Negative 1 and 1.
Negative 1 times negative 1 is not positive 2. Wrong. I'm positive. 1 times 1 is 1. Yes. There it is. Negative 2 and positive 1. Negative 2. Nope. 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 How about positive 2? Oh, and minus 1. Is that going to work? No. This is not factorable, is it? Now, guys, look. Negative 2 would not work, and I'll show you why. What is negative 2 times positive 1?
Negative 2.
Not positive 2. So, you know what happens when you can't factor it? It's called prime. Okay, guys? So sometimes you are going to go and find something that is not factorable. In this particular case, gentlemen, that is not factorable. Nothing times anything equals negative 2, but when added together is negative 1. It won't work. Now, but what about negative 2 and positive 1, Mr. Morrow? That would have worked if it was x squared minus x minus 2. Then negative 2 times 1 would have been negative 2. Negative 2 plus 1 would have been negative 1. Okay? But that wasn't the case. So be careful, gentlemen. How about over here, number 7? Okay, let's do our setup. X, and then I've got positive 12, negative 3. 12 times negative 3 is negative 36. 12 minus 3 is 9. Absolutely, my brothers. Does that make sense? Easy, right? Yes, sir. So is that like what the final answer is? It's not like what the final answer is. That is the factored form of that trinomial. Yes, sir. Just like the rule said. Any other questions, gentlemen? Okay, let's move on. So a couple more examples. Wow, we got that one quick. We got our setup, y, what times what is negative 21? When added together is negative 4. My boy already said it. Negative 7 and positive 3. Because negative 7 times 3 is negative 21. Negative 3 plus negative 7 plus 3 is negative 4. Okay, how about this bad boy here, my brothers? X and X, negative 7 and positive 5. Negative 7 times 5 is negative 35. Negative 7 plus 5 is negative 2. Fantastic. How about over here? We got our setup. Okay. I can hear the same people giving me the answers, and I'm going to tell you what's going to happen. For those people who know their multiplication tables And for those people who have been practicing it, like I have been telling you since day one of this class, this is going to be a joke because you're going to know your times tables. For those of you who don't know the times tables very well, I'm not trying to be a jerk, but it's going to be very tough. I would suggest you work on it. So it's going to be -9, +8 for sure. Sir. Yeah, he had already said it. Thank you, Papa. So that's -9 and +8. Does that make sense, boys? Promise? Okay. Now, continuing factoring trinomials, guys. Now we're going to learn about how to factor a trinomial in the form of ax squared plus bx plus c. That a, okay, that a, this a right here, a is going to always be greater than 1. Not equal to 1, because if it's equal to 1, then we have this format, right? Right, guys? Remember we already saw these, okay? But now we have ax squared, so a is greater than 1. So we're going to learn it just like the last time. We're going to actually go through the procedures one by one with an example. And the first one we're going to factor out is 5x squared plus 11x plus 2. Again, there are several ways to skin this cat, guys. Okay? So a lot of ways to do it. Please do not be intimidated. If you know of a way that works for you and you love it and it works all the time, God bless you. I'm not going to punish you or feel insulted because you have a different method. I'm not here to feel good about myself. I'm here to help you learn and feel good about yourself. So remember, if you have a method that works for you, awesome. Use it. Now, not to be conceited, but this is the best way though. Step 1, similar to the last step, how you had the x and the x, and remember you took half of the exponent? Well, this time you're going to do exactly the same thing, but whatever the a is, attach it to both. So you got 5x, 5x. Don't do anything to that 5, drop it, that's my a. And then the x, of course, divide the exponent by 2. So that's going to be 5x, 5x. Is everyone with me so far? Sir. Okay. Please, let's not go into will that equal 25x squared. Let's pretend that Mr. Moore knows what he's talking about and just follow my directions. Okay? Thank you. Can we agree to do that? And then after that, if you find a flaw with my method, you can tell me. Is that fair? Okay, thank you, guys. So does everyone understand that right now, part of the method is exactly, I don't care what 5x times 5x is. I didn't ask that. I said in your setup, ax, ax. Does everyone see how and why I did that? Okay, so that's number 1. Number 2, a little bit different. I'm going to want you to multiply a times c. And that's going to be your new c. So a times c equals the new c, which in this case is 10. Does that make sense so far as well? Remember, this is not mathematical, really, what I'm going to teach you. It's a trick. This is a trick. It's called the Cuban method. This is how they do it in Cuba. And the reason I'm teaching you this is because this old Cuban guy, okay, a friend of my father's, who was a math teacher of my father, taught me this trick. So I call it the Cuban method, okay? And it's not just me. A lot of different people know this method. But this is a trick. So please, don't try to make sense of it until the end, please. So step 2, a times c gives you your new c, and your new c is 10 in this case. Now that you have your new c, it's identical to the first trinomial procedure. What number times what number equals, oh, but it's not the b. Man, I can't believe I made this mistake. I apologize. What number times what other number equals the new c, but when added together equals b. So let's think about that, guys. What times what equals 10, but when added together is 11? 1 and 10. So 10 times 1 is 10. 10 plus 1 is 11. Step 4, plug it into your answers, into setup. So I got 5x plus 10 times 5x plus 1. Is everyone with me so far? Because I don't want to go to the next step until everyone sees what I've done. I'm not ignoring you. And don't ask me again, isn't this that, isn't that this? Don't ask me that yet. Wait till I finish. Everything is going to make sense in just 2 seconds. Yes, sir. What times what is the new C, which is 10, but when added together is the B, which is 11. 10 plus 1, 10 times 1 is 10. That equals the new C. And 10 plus 1 is 11. That equals the B, the middle. Is everyone with me? Now, step 5 says imaginary factoring. Okay. The reason why I say imaginary. Guys, if I factor a GCF out of something, don't I have to put the GCF outside of the leftovers? Right? Well, in this particular case, and only this case, because this is a trick, you're going to artificially, imaginarily factor the GCF from any of the terms if possible. So what goes into 5x and 10? So you divide it by 5, right? Normally this would be 5x plus 2, correct? But this is a trick, my brothers. So I'm just going to divide the 5 out, and I am not going to put the GCF out. I am not. It's just going to be 5x plus 1 times x plus 2. So how did I do that? I divided this by 5. Okay, that's my x plus 2. Do I have any common terms here that I can factor out? But yeah, but other than 1. You're done. Does that make sense, gentlemen? Guys? Does that make sense? Promise? Because we're going to do a bunch of examples now. Yes, sir.
Also, it's got x squared plus 10 equals parentheses plus, how we went back to before.
You mean grouping?
Yeah.
Yes. Okay. Jimmy just finished asking a very important question, and this is because he has a good memory. He was asking, can we do it the grouping method? And you can. So let's just remember 5x squared plus 11x plus 2. Okay. 5x squared plus 11x plus 2. Okay. Let's think about what Jimmy was saying, because he's right. We can do this by grouping. But what's the first thing we got to do? We're going to do this by grouping. You first got to multiply the A and the C, right? And you got to find that that's 10. That's my new C. So you're still going to have to ask yourself, okay, 5x squared, and then you're going to have, and you have your plus 2, okay? So you're going to ask yourself, what times what, okay, is going to give me 10, but when added together, gives me 11x. Isn't that going to be plus a 10x and plus a 1x? Do you guys just see what I did there? Do you guys just see what I did there? You sure? This is the grouping method. So now, boom, 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 boom. Here, this is going to be 5x, and it's going to be an x plus 2. Here, you're going to pull out a 1, and this is your x plus 2. This and this are the same, so that's x plus 2 times my leftovers of 5x plus 1. Please notice that that is identical to what I just did. In my opinion, I like my method better. But who cares what Mr. Morrow likes? You shouldn't care. You should care what makes more sense to you. So, my brother, I'm assuming since you mentioned that, you like this better. You like the grouping better. Okay, so I guess Jimmy's going to do it on the test by grouping. Good for him. How many of you like the other way better? Yeah, the Cuban method. Okay, some people like that better. The rest of you like grouping better? Then that's fine. Again, if you're going to do a grouping, let me just be fair and give you a good synopsis just one more time. Okay, so we could be fair. Come on, man. Okay. So to be fair, what's happening here is, first thing you got to do, if you're going to do split grouping, you still have to multiply A times C. And that will give you your 10. You got to do that. Then you have to ask yourself, okay, what times what gives me 10? But when added together gives me 11x. So you still got to ask the same questions. So you take your first term, your 5x, you add 10x to that. Then your last term, you leave it last, and you add the other 1x. Because 10 times 1 is 10, but 10 plus 1 is 11. And then from there, you can group it. Does that make sense for those of you that like grouping? Okay, now, I'm not going to do grouping today through these examples. I'm not saying that you can't, but I'm not going to, okay? Now, let's just flow through this one time, kind of watch what I'm doing. First thing I always do is my setup, just like I taught you. 3x, 3x. 3 times 2 is, so I cross this out, and now it's a 6. What times what is 6, but when added together is 5? 6 and negative 1, 6 times negative 1 is negative 6. That's wrong. Okay, positive 3 and positive 2. Check it out, guys. Artificial factor of 3. So that's x plus 1 times 3x plus 2. You're done. Goodbye. Have a good day. Now, the thing that most people forget is the artificial factor part. Sometimes they're human. They'll put a 3 out here. Do not. This is not true math. This is not true factoring. This is a trick that I'm using. So that's why I call it imaginary factoring. Please don't now go on a test, and if you see 3x squared minus 6x, and you go, oh, that factors out to be x plus 3. What about the GCF? Don't tell me, oh, but imaginary factoring. That's only for factoring trinomials where a, the coefficient of x squared, is larger than 1. You with me, guys? So the real answer is right there, like that. Next, 2 or 3. I'm going to go 6x, 6x. 6 times 5 is 30. 1 times what is 30, but when added together is 13? Positive 10, positive 8. Now look at this one. Here I can factor out a 2, so I'm going to get 3x plus 5. And then here I'm going to factor out a 3, so I'm going to get 2x plus 1. Done. Remember, those are imaginary factors, so I do not pull out the GCF to the front. That makes sense, boys? So far? Anthony, you got that, Bo? You sure, man? Thank you. All right, guys, let's continue. Okay, what's my setup? 2x and 2x. 2 times negative 7 is negative 14. I rewrite it there so I know it's there. What times what is negative 14, but when added together is negative 13? Negative 14 and positive 1. You see why now I have 2x and 2x on both of them? It doesn't matter where the negative 14 goes, does it? Doesn't matter where the 1 goes, does it? So now, imaginary factor. So I got x minus 7 times 2x plus 1. Done. Does that make sense? Yeah? Okay. Next. Okay, I'm going to have a little bit bigger numbers, but that's okay. 8x and 8x. What's 8 times 15? That's exactly right. That's 120. Now, here's the big one. What times what is 120, but when added together is 22?
Oh, I know. I got it. 12 to 10.
10 plus 12. Very good. 10 and 12. Okay, so I'm going to artificial factor from here a 2. So I get 4x plus 5. I'm going to artificial factor from here a 4. So I'm going to get 2x plus 3. Gentlemen, is this making sense? Promise? Okay. Example 6. My setup, 3x, 3x, 3 times 5 is 15. What times what is 15, but without it together is 16? Positive 15 and positive 1. Artificial factor of 3, so x plus 5 times 3x plus 1. Have a good day. You're done. Yes, sir.
Would it get, like, would it has to be negative?
Then you screwed up. If there has to be a negative and you have two positives and you messed up. Or it's prime.
That's what
It could be prime, but it's very rarely prime, guys. I don't want you now to go to the homework today and be like, oh, they're all prime because they're hard. No. Very rarely are they prime, my brothers. Very rarely. Thank you for asking, son. So this is 4x. 4x. Multiply. A times C is negative 12. That's my new C. So tell me, what times what is negative 12? But when I have to is positive 4.
6 and negative 2.
Positive 6 and negative 2. Artificial factor of 2. 2x plus 3. Artificial factor of 2. 2x minus 1. Yeah, wow, that's it. And that's it. You're golden. Does that make sense, gentlemen? Promise? Okay. You got all that down? Okay. Shh, guys, chill. Okay, now, I doubt we're going to get much further than this because we have announcements coming up soon. But let me just start, okay? When you're factoring special cases, don't let this scare you, okay? The first ones that you see here, the perfect squares, it's great to memorize them, but you really don't have to, okay? Let me explain why. Let's just work on the perfect squares for a second. Let's say I tell you 4x squared plus, let's see, 24x plus 9. Check this out, guys. Isn't this the same format that we just finished learning? An ax squared format? So can't I go like this? 4x and 4x. 4 times 9 is 36. What times what is 36, but when added together is 24?
8.
Wait, did I do this right? 3 and 2. No, that's sorry. This should be a 12 in here. My bad. Because wait, no. 3 times. Yes, that should be a 12. My bad. Sorry. So what times what is 36? But when I have to get is 12. Hey, so check it out, guys. Plus 6 plus 6. When I artificial factor a 2 from here and a 2 from here, don't I get 2x plus 3 times 2x plus 3? Isn't 2x plus 3 times 2x plus 3? Isn't that 2x plus 3 squared? So you don't need to know this format. Now, Mr. Morgan, why on earth do you teach it? Let me show you. Again, no, not because I'm crazy. 4x squared plus 12x plus 9. Check this out, guys. If you can recognize this, I'm not going to lie to you. I did not recognize these when I was a kid. So that's why I just showed you the shortcut, or not the shortcut, but another way to do it. Don't stress. You don't have to memorize the perfect squares. But if you can recognize this, check out how easy this is. This is what I have trained myself to do. Is this a perfect square? What is the square root of that? 2x. Is that a perfect square? Okay, 3. What's 2x times 3? Times 2? So it's 2x plus 3. Do you see what I just did there? Now, let's be honest. That takes time. I see it, and I just see it. Ooh, whoop-de-doo for me. I better see it. I've been doing this for a long time. So if you can't see it, which trust me, after the amount of homework I'm going to give you, you're going to see it. But if you don't see it, These types, you don't have to memorize. You can do the long way. You with me, guys? Now, difference of squares. And hey, by the way, do you guys remember that we already learned the reverse of this? Remember, if we square that when you multiply it, doesn't this turn out to be that? Do you guys remember that from the products, special products? So same thing with the difference of squares. When you have a term squared minus another term squared, I promise you, it will always factor out to the first term plus the second term times the first term minus the second term. For example, x squared minus 9. This is x plus 3, x minus 3. Done. Why? How did you get that? Okay. Is that a perfect square?
Yes.
Is that a perfect square? Are they being subtracted? That's a difference of squares. So when you have a perfect square minus another perfect square, the factored form of that is the first square root plus the second square root times the first square root minus the second square root. Does that make sense, guys? Okay? I'm just going to go over these. We're not going to do a lot of examples, but come on, guys. Let's motivate, huh? Sum of squares. This is no general form. Whenever you get a square root plus another square root, another perfect square rather, you simply put prime. You cannot factor out the sum of squares. Okay? You cannot factor out the sum of squares. Now, last two. Difference of cubes and sum of cubes. This is important. So the difference of cubes, a cubed minus b cubed, that is going to equal a minus b times a squared plus ab plus b squared. Now, that looks like Chinese, because I forgot to tell you one important thing. And very rarely do I see books tell you this. You have to first find the cube root of the first and second term. Now, let me explain what the heck I'm talking about. For example, if I tell you factor 8x cubed minus, actually let's do it that way, minus 27. Okay, first things first, guys, you have to recognize that this is a perfect cube and this is a perfect cube. First, you have to recognize that. Now, step one for this. What is the cube root of 8x cubed? 2x. Very good. That we're going to call my a. Step two. What is the cube root of 27? 3. That's going to be my b. Now, please, follow the directions here. Check it out. A minus b, right? Because this is a minus, right? So a minus b times a squared plus a times b plus b squared, which is 9. Not bad, right? Pretty easy. Same thing for the sum of cubes. Except for the sum of cubes, I have a minus here on that part. But let me show you that. Ow. Okay, so what have I told you? Let's just make it simple. X cubed plus 64. Now again, for those of you that are a little bit weak with multiplication, this is going to be very time consuming for you. But this is a perfect cube plus another perfect cube. So the first thing, what's the cube root of x cubed? X, that's my a value. What's the cube root of 64? It's 4. 8 times 8 is 64. Cube root means what number times itself 3 times gives me 64. And that's going to be 4, which equals my b value. Now once I find those two guys, it's easy. In this case, it's a sum of cubes. It's a plus b times a squared minus a times b plus b squared. Does that make sense, guys? Hello? Okay. For real? Promise? All right. Let's just continue a little bit until the bell rings. Okay. Factor each polynomial. Okay. Can anyone here recognize that this is a difference, that this is a perfect square? Okay, if you didn't, let's just show you how I would have done it if you didn't recognize it. X, X. What times what is 16 more to add together is 8? Plus 4, plus 4. So this is X plus 4 squared. Now, I would have known this because that's a perfect square, that's a perfect square. What's the square root of this first term? What's the square root of this second term? What's X times 4 times 2? 8x, so we know it's a perfect square, so I would have just gone x plus 4 squared. Are you guys with me there?
Yes.
Okay. Well, you could do it the long way, but let me try to show you the short way. Number 2. Okay, there's a difference of squares. There's going to be 3y plus 8 times 3y minus 8. And I promised that I would stop at the bell, so I'm going to keep my word. Actually, no, you guys are not seniors. We can continue. Okay. Does that make sense, guys? Hello?
Yes, Mr. Morrow.
Okay, I can see you guys are done for today. We will stop right here. We will stop right here. Give me 1 second.